Hey everyone, welcome back. Let's do some LeetCode today. Now, I'll come back to the roadmap because the daily problems lately have been a lot about, have been about dynamic programming recently. And that is something that I've not reached yet. As you can see, 1DP, 2DP is something that comes out of backtracking graphs, etc. So I'll at least, ramp up till trees and then go to dynamic programming answers. Because the thing is, like, I can solve it and I can try to understand the question and just give you the answer and give you in a video, but I won't really how should I say this, I won't be able to solve it on my own. Okay, I won't be able to solve the question on my own. I will have to look at the solution and I'll try to understand how the solution works. So that's not what I'm trying to achieve on this channel here. I'm just trying to create solution videos for questions that I understand how they're working, and then I'll provide you the best solution, or at least the solution that I came up with. So great. Now let's go to arrays and hashing. I will continue that and we'll go to the next question, product of array except self. Now this is the question here, product of array except self, and this is a very good question. It's medium and the logic behind it is quite complex, as in the best solution, which is a big O of a n solution. It indeed is a bit complex, so I understand why it's medium, but it's one of the really good questions on this platform. So what exactly is the question? Now let's skip this. I'll just directly go to the example. What we have to do is, for this every array, what you have to do is at this index or at every index, you have to get the product of all the elements which are not at that index. For example, these at index 0, we have the element 1. So I need to get the product of all the other elements, which is 4, 3, 2. 4, 3, 2, 24. Similarly, at 2, 4, 3, 12, 1. 12 into 1, 1, 12. At 3, 2, 4, 8. At 4, 3, 2, 6, 6 into 1, 1. So 6 into 1, 6. There we go. So that's how it works. Basically, product at that index except self. Similarly for this, as you can see here, the at -1, it's -3 into 3 is -3, -3 into 0 is 0. So basically, we'll only have a solution at index 0, and at index 0, it will be -3 minus 3, which is +3, +3 is 9. There we go. There it is. Now let's go to the whiteboard and understand how we can solve this question. Okay, so I'll take the first example. Great. Now I have 1, 2, 3, 4. I'll also store the indexes 0, 1, 2. I'll show you. I won't store, I'll show you the indexes. Now what we want at the end is 24, 12, 8, 6. Now the most brute force method to solve this question would be to multiply everything, which is to get a total solution. In this case, it would be 24, and then divide every element. Divide 24 by every element. So if I divide 24 by 1, 24, 24 by 2, 12, 23, 8, 24 by 4 is 6. There we go, 24, 12, 8, 6. But according to the question, if you check the question now, we'll see that it mentions that we cannot use the division operation. So if we cannot use the division operation, then we can't use this brute force method, right? We'll have to find some other way. So this is not the solution that we can go with, but there are other solutions. Now let's see the other solution. What if I analyze every answer as product of its prefix and suffix? For example, for 1, it would be all of a suffix, right? So 1, all the elements that come after 1 will be the product of it. Prefix doesn't exist here, so we won't be calculating prefix solution. So 2 into 3 into 4 would be 24. I'll get 24 here. And then for this one, prefix suffix would be 2's prefix is 1. So let me have that in now different color. Prefix product is 1 and suffix product is, what is yellow? Yeah, 3 into 4, 12. So 1 into 12 is 12. There we go, 12. For 3, the prefix product is 2 into 1, 2. And the suffix product is 4. 4 to 8. There you go, 8. And for 4, there are no suffix, there's only prefix. So 3 into 2 into 1, 6. There we go, 24, 12, 8, 6. So we will be solving this using suffix and prefix. Now, how will we solve or create these suffix and prefix arrays? What we can do is, we can have a result array. Now, the result array will have all ones. 1, 1, 1, 1. Okay, this is the result. Now, what I'll do is, I'll ignore the first one. Okay, we'll start with the second index. Starting with the second index, this is nums, the given nums. Okay, I'll assign the previous index as a multiplication of the next index. For example, result of, I'll assign the current index as a multiplication of the previous index. For example, result of I, if I were to start with 1 here, at this index, what it will be is 1 into 1. So this into this. So we have this again, 1. Great. So 1. Now at this index, it will be 1 into nums of 2, which is 2. So now this is 2. At this index, it will be 3 into 2. Sorry, not at that, sorry. At this index, it will be 3. Okay, this is the current index that I'm going for. Okay, into 2. So, oh, sorry, my bad. Right. So, okay, I'll start from the beginning. Here, 1 into 1, 1. Sorry, here, 1 into 1, 1. Then here, 1 into 2, 2. Okay. 2. Okay. Now it's here now. 2 into 3, 6. Okay. So this is the prefix product now. Now we'll take the suffix. How will we calculate the suffix now? We'll store the suffix in a variable. Okay. And the suffix will be basically multiplied with nums. So now what we'll do is we'll loop again, but in reverse order. We'll go through the nums array list in reverse order. So we are at 4 now. Okay. Suffix would be, first we will multiply 6 into suffix. So suffix initially is 1. So 6 into 1 becomes 6. So the let me emphasize this. Final answer here is 6. Okay. Now the index is here. But before moving the index, I'll multiply 4 with the suffix. So now the suffix is 4. Okay. Let me actually clear it a bit. Suffix is 4. Where is my eraser? Yeah. I'm going to do this thing. And here we have, I need the brush. Here we have 6. Let me increase the, yeah, there we go. Here we have 6. Now the index is here. The suffix is 4. Value is 2. I'll multiply the result value with the suffix value. Now the value is 8. Value is 8. Index is here. But before moving this index, wait, I'll multiply the value at nums at this index with suffix. So this becomes 12. Now we are at this index 12 into the current value that I have already at. I already have at the result. So it basically indexes this thing. Okay, 0 1. So 12. Let me remove this. Now it's 12. Now before I move to the 0th index, I'll multiply nums at that index, at index 1, with this, which is 24. And then I'll move this to 24, because result of I into suffix, whatever the value is suffix. There we go, 24, 12, 8, 6. Now let's code. So this is fairly easy. First we'll create the result array. That's going to be a small one. And so we basically have ones for the length of entire nums. So the length would be exactly equal to nums length. Now let's create the prefix products. Since we are skipping the first element and we are starting with the first index, we'll use the range 1 to length of nums. And I'll multiply it with the value at the previous index. This is a suffix product. Now we'll go, I will loop on nums on the reverse order. So basically we are multiplying the suffix with the current value at index I on the nums list that we have been provided with, and for every result we are first multiplying the actual value that already exists in that result array with the suffix product. And since suffix product is 1 initially, the last value will be the prefix value that you got. There we go. Now we can return result. I'll run this. It's quite efficient, 57 milliseconds. Let's submit it. And there you go. As you can see, the runtime is quite efficient, but C is not that good. I do not have a way of solving it in big of 1 space-time compressibility yet. I will look into it and create a video in the future. But yeah, this is a worthy bonus point. We'll definitely solve this someday. Yeah, that's it. I'll see you in the next one.